Hey everybody, we are up to 3-7 and we're doing proof by reductio ad absurdum in Latin, or indirect proof in plain English. This is a technique we use in proving something when it's often prove that something is not possible, or prove that you can't do this, or you can't have that, or even prove that something is not finite, which is infinite. All right? So the way you do it is, I think probably I'll show you by example. So for instance, prove that it is impossible, not possible, to have a regular polygon with a 167-degree angle. Well, how do you prove something like this? How do you prove that it's impossible? Well, you say, suppose it is true, and then you prove that that assumption's crazy. And then you go back and say, well, then this must be the case, that it's not possible. All right, so the steps for doing this are: 1, clearly state what you're trying to define or prove. Clearly state proposition, okay? Clearly state that proposition. I've done that. This is step 1. Step 2, then, we are going to negate. That means do the exact opposite. Negate proposition. Or assume temporarily the opposite. So in this case, we're going to assume that it is possible. We're going to say, suppose it is possible to have a regular polygon with an angle of 167 degrees. All right? Step 3 then is work through the logical consequences. Okay, now this is open-ended. And it has to do with each problem being a little bit different. It's a geometry, you're going to go to a diagram. If it's something like this, you're going to start talking about, well, what does it mean to have a regular polygon and its angle formulas. Each problem will be a little bit different, so this is a hard step to kind of figure out, but you'll get the idea with practice. Step 4 then is to show a contradiction, that there's something wrong. Okay, and once you've shown that there's a crazy consequence, you've reduced something to the absurd, then you know that assumption 2, okay, then or therefore step 2 is false. Okay, so if step 2 is false, then by what's called the law of the excluded middle, either something is or it isn't in a lot of our mathematical statements. And so a number is either even or it's odd. It can't be both. So if you prove that a number is not even, then it must be odd. If we prove that step 2 is false, then you negate the negation, or you have the opposite of your proposition that's crazy. So you go back to your original statement being proven true. And so we say then 3 dots stands for therefore. Step number 1, or your original problem, step 1 is true. Okay? If you can prove that your assumption to the opposite was false and crazy. Alright, so how do I do that? I'm going to erase my original writing up here. Prove that it is impossible to have a regular polygon with a 167-degree angle. Okay? So I'll say, suppose, step 2, suppose is the measure. Okay. Well, if that's the case, then our formula that we know, that we can figure out the measure of one angle, our shortcut formula, if you remember from our chart, is that we say it's 180 degrees minus 360 over the number of sides we've got. Because this will be our exterior angle. Once we find the exterior angle, we can subtract from 180, and that's our interior angle, and that's 167 degrees. Okay? Well, if I do my math, I subtract 180 from both sides, then I'm going to get negative 360 equals negative 13. Okay? And then I can make them both positive. All right? And if I multiply both sides by n, I'll get n to cancel here, and I'll say 13 times n is equal to 360. All right. So if I divide 360 by 13, I'm going to get what n is. And if I do that, I get an angle measure. I get a side in my polygon of 27.7 sides. So n equals 27.7. Well, there's no way that I can have a polygon that has 27.7 sides in it. It has to be a whole number. So that's the absurdity, that's the contradiction. So because I assume that you could have a 167-degree angle, and then I've shown that that's crazy because I'd have not a round number of sides in my polygon, that this step number 2 must be false, therefore the original statement must be true, and that it is impossible to have a 167-degree angle measure for a regular polygon. Okay? It's kind of crazy, kind of backwards, but that's how you do it. You might have to replay that in slow motion, but that is indirect proof. Okay, so I have one more example for you to think about, and that has to do with, it's a very famous example. It goes way back to ancient Greek times. It shows up in Euclid's Elements, and it's proof that there are an infinite number of prime numbers. Primes. Okay, so how do you do that? How do you prove that there's not a finite number of primes? That's right, you assume that there is some finite number of primes, then you show that there's a contradiction. Alright? So again, indirect proof, it's all about assuming the opposite of what you're trying to show, and then show that there's a problem with that, and that means your original assumption of the opposite was false, so your original statement is true. Okay, so prove that there are an infinite number of primes. Step number 1, there's our statement. Step number 2, assume a finite, that means an ending, a finite number. Okay, well, if there's a finite number of primes, we could write a list of them, because there's a last one. You don't need to worry about how you find the last one, but suppose, just as an idea, there was a last one. So you could have P1, and you could have P2, and you could have P3. Whatever they are, we could list out all the prime numbers, and we could go dot, 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 and there's our last one, PL. There's our last prime number, because we're assuming that there is a finite number. Well, if I take all of these, right, and I multiply them all together, I'm going to get a big number. And it's definitely going to be bigger than my last prime number. And if I multiply them all together, and then I add 1 onto that, I'm going to have a new number, and I won't have any numbers that are able to divide into it, because there's always going to be that remainder. If you think about it, that's the way it works, right? So if you've got a prime number, no other number divides into it. And if I've got all of the possible candidates multiplied together, and then I've tacked on a 1, I can now not divide in any numbers into it. So this is a new prime number, okay? Alright, so that's a new prime number. Except that that's a contradiction, because I've assumed that there is a last prime number right there, but now I've found a new one that's bigger than the last one. So that's a contradiction, and that's absurd. So therefore, dot, dot, dot is therefore, step number 2 is crazy. So therefore, step number 1 is true. Okay? And that's proof by indirect reasoning or proof by reductio ad absurdum. All right? Take a look at the homework, and good luck.